the way to set this up is that when we talk about like cybernetics, we have all these issues of organization. The homeostasis is a subset of organizational theory. And so you have to ask yourself, like, why were people so concerned with the question of organization? And it turns out that if you trace this back, it is the kind of ontological shock that the second law of thermodynamics introduced. And so, put it briefly, like, this is the idea that, like, when there is a conversion of heat, when work is done, heat is lost. And so if you extrapolate that to like the scale of the universe, you have this tendency in the universe towards disorganization, towards breakdown, towards decay. And what makes this important is that it arises right on the heels of, this kind of like right on the heels of the Industrial Revolution. And the Industrial Revolution, is all about progress. We're striving eternally towards this better world. And so entropy comes along and between like the 1840s and the 1860s, and it's just like a complete shock or blow to that, right? But started diving into this because I was curious about like the circumstances that produced our understanding of entropy, and it actually comes directly out from work on the steam engine. So like the steam engine, it's first deployed as a means of pumping water out of mines. In 1896, Thomas Savery introduced what was called the Savery engine. And this was the first like steam-powered water pump.
You said you said 1896. I think you mean 1698 is what.
Yes, yes, that's what my notes say. Sorry, I was looking at two different things simultaneously.
Just gotta make sure people get the
1698. Savery does the Savery engine, and then in 1712. Thomas Newcomen, he improves on the Savery engine, with what is called the atmospheric engine. And so like the way that the atmospheric engine works is that you basically have, what's the best way to put it? You kind of have like this big bowl, right? And it's got like a curved top, and inside the bowl you've got water, and underneath it you have coal. And so you heat the coal, the water turns to steam, and it's funneled up through the top into a cylinder, and it's got like a little regulator valve, right? And so when it's up in the cylinder, there is a injection of a small amount of cold water that goes through, and it spritzes this hot steam and cools it down immediately. Well, at the top of this is kind of a pumping mechanism. So the steam rises, it pushes the pumping mechanism up, the water comes in, and it makes the pump come down. I feel like we should, give people like a schematic diagram.
Yeah.
So I'm not sure it's that easy to describe. But basically what it does is it uses the cold water to create a vacuum. And so between like the oscillation between the creation of the vacuum and the hot steam, the pump mechanism just kind of goes. And this is actually considered one of like the first true instances of automation, right? Like it makes a self-propelling pumping apparatus through which water can be extracted from the mine. And so, after the atmospheric engine, there's kind of this mad rush to improve upon it. Like James Watts is a big guy that does this. And they do that where they add like additional chambers for cooling down steam, more sealants, so there's not like more heat loss. And the whole idea is like, how can we maximize our usage of heat with less coal? Because coal is costly. You want to this is economic concerns. And so in 1824, a guy named Sadi Carnot publishes work that it's called Reflections on the Motive Power of Fire. And what Sadie's trying to do is like design the best. He wants to discern like the universal principles in play in order to optimize the steam engine so water can be pumped more efficiently. And there's all kinds of like nationalistic imperatives there, because he wants, like France to have the best steam engine, because the best steam engine means the best industry means the best military might.
And then
right?
wait, I just want, if I may interject.
Go ahead. Interject at any point.
This is exactly parallel to, I want people to remember what we talked about in terms of the Pereire brothers, right? And their development of the railroad. So I think it's important. Well, you listen to this. This is the same kind of thing, same context.
Well, I think it's incredibly important that you mention the Pereire brothers, because Sadie's book is completely kind of neglected, right? And in this book, he does all kinds of like really interesting things where he like talks about heat as like not just the motive power of industry, but of like the universe itself. He's got this quote that I thought was really incredible. He said, "To heat are due the vast movements which take place on the earth. It causes the agitations of the atmosphere, the ascension of clouds, the fall of rain and meteors, the currents of water which channel the surface of the globe, and of which man has thus far employed but a small portion. Even earthquakes and volcanic eruptions are the result of heat. From this immense reservoir we may draw forth the moving force necessary for our purposes. Nature, in providing us with combustibles on all sides, has given us the power to produce, at all times and in all places, heat, and the impelling power which is the result of it. To develop this power, to appropriate it to our uses, is the object of heat machines."
Oh my God.
And he starts talking about like the universal motor, and listing all the different ways like heat through the steam engine is used. But this is completely neglected. Nobody reads it except for one French engineer who works for the Pereire brothers. He's working on their railroad. So like, I think it's really important that you mention them, because he's the one who's like, oh, there's something interesting happening in Sadie's work, and it applies to this grand industrial railroad project that we're working on. So he writes it, like he builds an entire work called Memoir of the Motive Power of Heat. This is 1834. And he builds off Sadie's work. And then his work is translated into German by another engineer named Johann Poggendorf. And this is 1843. And suddenly, like, everybody starts paying attention to like what Sadie Carnot was talking about. And what's important is that there's a thought experiment that Sadie does in the book. He's talking about, when the water spritzes, the cold water hits the heat is lost. That creates the vacuum. And he says, well, what if we could somehow trap that heat that is lost? We could funnel that back into the original state. We could preserve the heat that is lost and continually cycle it through. And so he raises this and he says, but we can't do that, because that would be a perpetual motion machine, and that's physically impossible. And so, it's just kind of like an aside. Like, most of this is relegated to a footnote. It's not even like a major point that is made in the book. But the German engineers, they're looking at this, and they like throws a switch in their head and like, oh no, like this is catastrophic, because we already are thinking of the entire universe as a heat machine. But if the universe is working, because the universe, is a machine and the machine works, then that means that the entire heat in the universe has to be dissipated. And if the universe is a machine and the heat's dissipating, that means that there is an end in which all heat is lost.
And that's important. Just point to just think about, because this is what the idea of mechanism itself is that it's like the clockwork, right? The heat machine,
exactly.
Right? It's like, this is not only, that's not a contemporary invention, but this is going back now into the 15th century, right? And to the fundamental idea of mechanism that's developing out of the Renaissance and into like Descartes, right? This is like really important.
It's incredibly important, for that. and also for the fact that like when you had the notion of progress like prior to this, the machine was the icon of progress, you know? Like it was what was delivering the better age. You know, this is the Industrial Revolution. This is the, you know, that phase of the Enlightenment. And suddenly the machine, which is the icon of progress, is the exact apparatus through which this disintegration is taking place. So it's like a profound, like, psychic shock. Because if the machine is striving us towards a perfect state, and the entire universe is striving us towards a perfect state, and the universe is a machine, and the machine loses heat, then that means that the thing that was supposed to take us to the golden age is actually driving us towards a state of decay. And so it's really in the wake of this that you see, you know, this is the point in which like ideas of like decadence and decline in the 1800s start to appear. And a lot of them
Weltschmerz, right? It's like, you know,
yeah,
nihilism, like Schopenhauer, like, you know, this is
exactly.
Is what we're talking about.
Yeah, exactly. And you can see it radiated across all these like different thinkers, artists, philosophers, you know, a lot of fiction in this time period. You know, like I think, is it H.G. Wells? I can't remember. Somebody writes like a, you know, a story where it's like the end of the earth, and it's just like Earth's been overtaken with nature, and the sun is just this kind of like slowly dimming red orb, like lazily circulating around it. Like this is the mentality. Like this is like, you know, the realization of entropy.
It's a really, I don't know. It just like freaks me out in terms of how bizarre the psychology of it is, because really what they're what's having this profound transformation here is that they're thinking on this universal, literally universal scale of the entire universe. Has like basically a set amount of potential work that it can ever do, right?
Exactly.
And so they're like already at that stage, like worried that they're going to run out of work that the universe can do. It's like, you know, how can they? That's like, how can that bother you in a contemporary setting of like something that you're not ever going to have to deal with? But this is like exactly what their psychology. That's where it's taking them through their universalization and stuff.
It's really funny, like, because I mentioned this to Thomas Moynihan. He wrote a really interesting book called X Risk on extinction, and so like I brought this up to him because he's starting to look more at like the history of thermodynamics and stuff, and he showed me a letter that, you know, William James, the American pragmatist, wrote to another American thinker named Henry Adams. And, you know, Henry Adams was like raising this question. He's like, oh, everything's running out. We're going to die. And William James is like, I don't know what everybody's talking about. This is on like such a Promethean time scale that this is literally not even an issue. So I don't know why people are even worrying about it. But I think that there were like other factors in play. And, you know, I'm not going to digress too much into this, but this was the period of the Long Depression as well. You know, this 1870s through 1890s. France had lost its war to Germany, you know, with Germany at this time period. So there was a lot of that disappointment happening. So I think that there were probably like more localizable factors that were happening that were kind of
This is the we just have actually even talked about this before, the general economic crisis.
Because this is the same one that produces monopolies. Yeah, and so like it overlaps in time, so I think that there's kind of a profound connection. Like there was like a general malaise, and people articulated it through this kind of entropic paradigm. I'm curious, like if it had been an economic boom time, and these had been like discovered, you know, this principle had been like, you know, happened upon, would it have been such a psychic shock? I'm not sure that it like really would have been. But
yeah, well, it's also like what we were talking about before, with just like cybernetics in general, right? Is that it's like the teleological component of it, and the kind of implications that has for your entire project in the present, right? This is like, you know, I was talking about that less wrong kind of stupid rationalism stuff. It's, you know, and you know how all their kind of thought experiments, if they can be called such, kind of involve like, knowing about future states and like, extreme hypotheticals and like, deciding how many people have to die in the present or whatever based on that.
Yeah.
I think it's a kind of a similar thing, is that it's it is kind of a feedback mechanism of belief here that's being enforced with regards to the teleological end, because they're treating that end of like kind of the machine universe and their like control over it. Their ultimate, like at the end of when Revelations happens and the seals are broken and stuff, is that they're thinking that by then they're going to be like, the machine masters of literally the entire universal mechanism, the heat machine, right? And they'll be the masters of it. And so, that is obviously not something that is a literal ambition of theirs, but it's, baked into their worldview enough where it's like having that challenged, like kind of overthrows the validity of the overall teleological principle that is ordering all their activity in the present, right?
Yeah. Okay. Yeah. That's an absolutely perfect way of framing it, because it's really like a shock to because they already have the notions, like the notions of like equilibrium are already kind of like existent in culture at this point, and so it's like a system heading towards like pure entropy, like a heat death scenario. That is an equilibrium state. It's just not the kind that you want.
Yeah, and it's there's so many different kind of factors being drawn into this. It's actually really interesting when you think about it, because then this is when the oil industry is developing. So you have the idea of all the different combustibles, like you said, that are all surrounding us all over. It's like, well, this is kerosene and crude oil that's being discovered at the same time. So it's like, it's very it's very intricate.
Yeah, this is something I want to explore more, because like I feel that there's a really like profound conjunction between these sides, and the only work that I've seen that has really tackled it is by a guy named Anson Robbenbach, and he wrote a book called The Human Motor, and he only treats it kind of briefly, because like what he's more interested in is the notion of fatigue that arises in this time, like in the context of like work, like actual like physical labor, because if the human body is a machine, the human body is converting heat, then the human body is losing heat through this entropic process, which it gets coupled to the idea of fatigue. You get tired when you work, and so like there's all this attempts to kind of control and regulate labor in order to maximize its energy potential, and this is what things like scientific management or Taylorism ends up like emerging out from.
Yeah, absolutely.
So it creeps into all these like different dimensions. One that does really stand out to me because of the later like Wiener kind of like resonance is Henri Bergson and his whole idea of creative evolution. If you go into creative evolution, he actually talks about entropy and the second law of thermodynamics, and he calls it a metaphysical principle. And he says, Clausius, who's one of the German figures who ends up like formalizing, he's like, Clausius has proposed this metaphysical principle. All life is on a downward slope into disorganization. But he says, like, but there's another direction. Life also has a tendency towards greater organization, and it's these two directions that you kind of have to grapple with, and this is an idea, in the 1890s, he's trying to articulate the idea of negative entropy, neg entropy, because it's like the reversal of this process. There you have a tendency towards disorganization. You have a tendency towards higher states of organization. And so at the same time as this, you had another, like the idea of what was called Maxwell's demon. And Maxwell's demon proposed a thought experiment in which you had multiple chambers, say like the chambers in a steam engine. And there was a demon who opened and closed a gate really rapidly, and he would only let certain particles through. And so in this, the idea was that like all the hot particles would go to one chamber because they move faster, and all the cooler particles would stay in the original chamber, and this would technically reverse the second law of thermodynamics. And so like in these two ideas, you have like on the one hand the idea of like life itself striving towards better organization, and the other one you have the idea that there is a way to preserve heat if only you knew how to properly allocate the molecules. And so you can see in that there is also
a Planner's problem.
A Planner's problem. How do you properly allocate
oh my gosh
every molecule in order to prevent the ultimate loss of heat? How do you preserve it? And so when you start leaping forward, a lot of the proto-cyberneticians start building on Maxwell's daemon. And it's like, well, what if Maxwell's daemon, was inputting information from his environment in order to make the decision about when to open and close the gates? What if the gate was connected to mechanical gears that drove a machine? These are all like the various iterations of it that started coming out. At the same time, you had Schrodinger. He came out with this thing called What is Life? And this is the first time that neg entropy was ever properly articulated. And he called life something that like drinks order from its environment. Like life is this localizable little, speck in the cosmos of negative entropy where it like takes in inputs and produces order from them and staves off this decay process. And that's what, when we saw in Wiener, when he's talking about the pattern that is life is a message, he's drawing on what Schrodinger is saying about like life is organization. The organization is pattern and it perpetuates itself. It's the same thing that Bergson is saying. And then you have these other people who are taking the Maxwell's daemon into what ends up basically being computation, where the daemon is the computer that can process the information problem to allocate all the molecules. And so in cybernetics, all these different things end up converging. And that's what they're concerned about, is an organizational problem about how do you stave off decay processes, how do you stop entropy. And so in a lot of ways, the steam engine is what gives the cybernetics.